One. In this video, I'm going to perform the three main HLS steps, which are the resource allocation and resource scheduling and binding by using the commercial HLS tool, which is provided to us by an AC company. So to do so, I need to create a new workplace in the beginning, and I'm going to give it the name of the project that I want to do. It's going to be like finding the average for and 8 numbers, and after that I'm going so I call the work space as IV8 and I go create and create. The next step to do the project is to give the project options that we need. We should now determine the maximum frequency, so I'm gonna extend this. It's gonna be like 2000, which will give us 15 megahertz, and the FPGA device that we are going to use, since we have the DE1 SOC FPGA board. So I'm going to choose the Cyclone V, and the speed grade is going to be -6 for the device, and the device family name is 5CSEMA5. Alright, and the packaging is FC31. Alright. And I'll make sure that I'm choosing the logic synthesis tool Quartus. And our next part will be adding the required library to run the software. So I'm going to add the basic library, which I already have the file for them provided us by the professor. Sorry, not there, here at the HLS, and here we are. We have added this file contains the delay and area information of basic logic gates, and the next thing is to add the functional unit library. I'll go to here and choose the downloads, and here we are. This is the functional library, and I'm gonna delete the rest. All right. Okay, and this library contains the area and delay information as well for the functional units of the different size. Like after we finished, I'm going to click on apply. Okay, and it generates the project here with all the required folders and tabs. So I'm going to add the C++ code for the project. So double click on it, and it's been added here. And actually, we've just done the allocation, the first part, which is the allocation part, and right now we are going to do the scheduling, but after I run this code. Okay, so this is the code which is written in C++, and it shows us how to calculate the average for 8 numbers. And this is the ANSI testbench file, which contains to verify the design after we convert it from the high-level language to the RTL language. Next thing, I'm going to parse the design to see if there's any syntax error, and it went very fine, and it generates for us the AVE8.c directory, which contains the light blue folders here, and it generates the .iff successfully. That means the parsing went in a good shape. I'm going to click on here and check the synthesis option to set up the scheduling mode option, and I'm going to choose the automatic scheduling for this, and after that I will click on OK. All right, so next things is going to do is, after I've done with the scheduling part, I will go to setting up the constraint file. So I'll go to generate constraint and generate flib and functional unit constraints file to the design. So I will get this window. I'll make sure that to generate the files, the flib and the functions. So I'll click on this, and after that I should make sure I'll set the unit count to maximize to 10. All right, and I'll click on generate. So right now it's generating all the function files, as we can see here. So if I double click on it on here, right click, sorry, and open this window, I will see that we have 4 8-bit adders, unsigned adders, and 3 12-bit unsigned adders as well. Okay, Cool. So our next part will go and review, or after we reviewed, I'm going to convert the C++ program into RTL, which is depending on the programming language that I want, whether it's Verilog or VHDL. To do so, I will go to the light blue folder, right click on it, and I'll click on Generate, Synthesize, Generate RTL option. Okay. And now it's generating. Yes. Do you want to reload it? Sure. So after I reload it, as we can see here, it shows the quality of result report, which contains a summary about the RTL design that we have. So the LUTs that we have designed 69, registers 64, and so on. And the latency, that means it's gonna finish, it will need 1 clock cycle to finish the operation. And the critical path delay, which shows the delay of the circuit, which is 2.05. So after we're done with this, let me see the RTL design of the uh, C++ code. And to do so, I will go to the same option and synthesis show result, data path, and here we are. These are the four, as we can see from here. Sorry, yeah, this one. Yeah, sorry. Yes, good. So these are the four adders and the three adders for the design, and it went perfectly for us. So our next thing is, after we have done with the scheduling part, I'm going to run the logic synthesis for the design. Then I'm going to close this, right click on the light blue folder, and I'm going to choose logic synthesis option, generate script. After I make sure that I'm using the family name and device name, all of them are correct, and right now I'm going to execute and generate the hardware, the Verilog code for the design, so I can run it on Quartus. So I'm going to click on execute, and it's running right now, and it shows up some information. Okay, so after we've done, we can see right now in the library right now, here it will generate this red folder for us, which contains the RTL design in Verilog. As we can see, this is the Verilog code, and it gives to us the tickle file, which has all the information about the family device and the thing we need to our design. All right, so after we got this, our next step will be running this Verilog file on Quartus software. All right, to do this, I need to make sure first that I'm adding the right path for Quartus software from tools. I'll choose options, yeah, here, and everything looks good. I'll close this window, and next thing will be, after that, go here, right click on it, right click on the blue folder and go to logic synthesis. It will give us the two options, which the first one will run the Quartus on the command line, and the second one will show us the graphical user interface for the. So I'm going to go and click on this. So it's gonna take some time, all right, based on so it's running the QPF file, and based on the server itself. So I'm going to wait until it runs. Now it's running. So it gives us this error. I need to make sure that I'm typing the same exact device name here, which is 5CSEMA5, and I'm going to save this and then go to logic. And it's gonna take like some time to synthesize everything. So I'll wait until it's finished. Okay, so after we corrected the family device, and let me make sure that it's correct here. 5ME, C6. Okay, cool. And right now I'll be able to run it on, but it says another process is working, so I should wait until it's finished. Yes, please wait a little. All right. So this kind of, debugging you need to do and make sure everything is correct. Otherwise, you will not be able to run the software itself. Right now, it's taking some time. It's passing all things. It's running the Quartus software. And yeah, cool. So all this problem happens because I didn't type the device name in a correct way. That's the main reason that caused this problem. So it's loading right now. I'm still waiting for it. It's gonna take like 13 minutes, 13 seconds to 1 minute to finish. All right, so right now it's compiling or whatever it does, and I'm still waiting for it to be opened. Yes, cool. It's giving some progress here in the console window. That's awesome. Yes, and now it's running the QPF file, and here we are. We go. We got the Quartus. Wow. All right. So after we got this, I want to make sure that the files are. So I got the Verilog file and the SDC file, and I'm going to open it. Awesome. This is the output input. This is the output for the design, and the clock will reset. So if I compile it right now, it should give me, the same exact result. Okay, cool. So after we have run the C++ code and it can be converted to the Verilog code, and now we are running the Verilog code. Our next step will be verifying the design and tested by testing the both code, the C++ and the Verilog code, to see and provide them with the required input to see how they perform and whether they are giving the exact result to the design or not. So that will be our next part. All right, to do so right now, I think it's going to be work. That's fine. And after it finishes, I'm going to show you the RTL design and for all these things. Okay, I'll go to tools right now, netlist over here, and here is our hardware circuit. Cool. So I'm going to close the Quartus for now and go to the next part. Okay, and see sorry. Yes. And I'm back here and verify the design. The first thing I need to do to verify the design, go here to the simulation work and create a new scenario. And I will name the scenario AVE8 software underscore software. All right, so that, as long as software, that means the behavioral design with the C++ code. And I should choose the C++, click on OK. Now, after I choose all of this, I should go to the build and choose the preprocessor definitions of the C language. And yeah, everything is set. And set apply. All right. So after that, as we can see here from this window, it added for us a purple window. It has everything for it. So I'm going to create a new scenario for it. So that's where we get all things. So the first thing I need to do is to import the input file that I will give to the design. Import, this is the input. Okay, yes. And after that, I will go to simulation to see if the design. So I got this error. This error is very normal because we don't have this file installed in our server. So I'll go and implement it from the terminal itself. So I need to go to the directory where I saved the project. So it's gonna be like home in the directory ska. All right, so I'm gonna choose cd ska 24. That's me 001. Sorry. Okay, and yeah, cool. If I press list, I will go to the AV8, AV8, CD, AV8. Yeah, no, I'm in third. Sorry. Now I'll come back again. Yeah, CD, AV8. Okay, list all of this. Yes. So I didn't get anything here. That means I should go back to the software and press on simulation. If I didn't get anything, that means I need to do these steps or go to the project where I saved the design here and here, AV8 simulation directory. Yes, this one, and I should take this path. Okay, copy and back again to the terminal. cd Control Shift V. Yes, list. I'll go to the AVE. Okay, then I will create. Yeah, I will create the file. Yes, and as we can see here, it generates the .exe file, and then I need to run this file to see the output file here. Okay, so I'll come back, and as we can see here, I will run this. No, not this command. AVEXE. Yeah, cool. Now it generates for us the output file, and this is the final result of the program in software. Our next part is go and verify the hardware by verifying the VHDL code. All right, so I'm going to create a new scenario and see RTL, only RTL, and it's going to be AV8 underscore RTL. All right, I will choose the model sim, and after that, the name of the scenario is going to be RTL. All right, it's cool, and I'll make sure that I will choose write a recycle here. This will be the value of to the file inputs. Okay, and that will enable for us the data regex of the pattern. I want them in decimal, and yes, the simulation signal dumps. I want to generate the VCD file, but not all of them, just the ports. Yes, and yeah, cool. And after that, I'll generate the test bench. Now it has been generating the test bench file here, as we can see here. I'm going to simulate the program, and as you can see, yeah, cool. Generate the VCD file. Okay, and generate the output for the file. But that means I didn't include any inputs for it. So to include that, I should go to the file and copy the input and output. Copy them, go here. This is the RTL design, and paste them here and rename them. Give the input file the exact name that we gave to the input in the entity. So I was declared as input 0.clv and delete this one, and the output should be also rename to output 0.clv, and good. After I finish, I will come back go back to the RTL and still click on simulation. So it's generating. See, it's added for us the input and the output, and it's updated the result of yes. We are in good shape. And we have to make sure that the CLV file should be exactly the same as the result, of the output file. Otherwise, the conversion from the software to the RTL will be not correct, and it's good right now. Okay, so after that, I'm going to take there's the waveform, so the VZV file. If I double click on it or just open it, should be opened on GTK Wave, but here in our server it's not installed. So I've prepared a sample for part 2. And as we can see here, it will give us something nice like this. Okay, so you can see the clock, the reset, the inputs, and the values of the average are displayed on the 7 segment as we can see here. And yeah, that's all of it. Thank you so much for watching. Goodbye.